Today we're looking at Glencoe Accelerated Math, Lesson 5.3, which is on complex fractions and unit rates. So yesterday we found the unit rate. That was finding how some quantity compared to one of something else. Like the number of miles per hour or the number of dollars per item at a grocery store. Today we're looking at that same concept in terms of fractional values. Okay, so we're going to review how to solve a complex fraction first. Then we will put that into the context of using that to find a unit rate. Okay? So, if we look in our book on page 194, example 1 gives us that we need to simplify 1/3 divided by 1/2. One-third divided by 1/2. This is a complex fraction because our numerator has a fraction in it, and our denominator has a fraction in it, which means that this is a much more complex system to solve. Okay? We talked about the fact that a fraction was simply a fancy division problem. We still have that. So to solve this problem, we're going to take this out of the fractional form and put it into the form of a division problem as 1/3 divided by 1/2. Now if you look at if you go to a different source for your information, some places solve this problem differently. Especially if there's a whole number denominator. I'm going to recommend that you do it this way every time because this way works every single time. Okay? Alright. We have 1/3 divided by 1/2. I cannot divide two fractions like this. I need to KCM that problem. The K still means keep. So we're still looking at 1/3. The C this time we're not changing to addition. We're going to change to multiplication.
I thought we always changed.
When we're dividing fractions, we do. The M stands for the multiplicative inverse. Remember, that was one of our most favoriteest words, the multiplicative inverse, which tells us that instead of 1/2, we're going to use 2/1. The multiplicative inverse, remember, are two fractions who multiply together to have a product of 1. When we were in elementary school, we called it the reciprocal, or we said that we flipped. I'm much better with the word reciprocal than I am the word flip. Let's elevate our academic language. I know. How dare I ask you to elevate our language? Okay. 1 times 2 is 2. 3 times 1 is 3 because we multiply straight across. So if we simplify 1/3 over 1/2, that simplifies to be 2/3. Questions?
No.
That's all we have to do.
Wait.
What?
Wait, what?
But it looks difficult. It looks complex. It looks like there's going to be like 80,000 steps to it, right? Well, maybe not 80,000, but it looks like there's going to be more steps. But really all we're doing, we're going to deconstruct this problem to write it as a division problem of fractions. Yes, ma'am?
Is there a way you could do it as a fraction still like that without changing it?
There is, but it's harder. Because that way we'd say that we take this and we multiply by the 2 and then we are dividing by a numerator of 1, which makes the number, which makes this just a quote-unquote whole number. It's harder. So that's why I said there are multiple ways to do it. Let's stick with this way. Because that way also only works if this term has a numerator of 1 in the denominator. Okay. So it can be done, but it's harder. This way is easy. Okay. Any other questions?
Is it?
That's all we have to do for example 1.
Have a picture of it?
It would all 5/3 lesson.
No, we're not done with all 5-3. I was asking if there were questions about example 1.
Oh, I was gonna say this is gonna be a short video.
rate stuff yet?
No. I thought that was.
No, we haven't done unit rate yet. Okay, so let's, because we're going to be using this to solve our unit rate problems today, what I'm going to do, we're going to freeze where we're at. We're going to stick with this, and we're going to look at this in terms of unit rate. So please, in your books, if you're following along, I know some of you like to follow along in your books, some of you like to see it up here first and then you look back later. We're going to look at page 195, example 3. Example 3 says that Josiah can jog 1 1/3 miles in 1/4 of an hour. We want to know how many miles per hour he can run. Okay? So, first of all, I have a complex fraction. Okay? And even within my complex fraction, I have a mixed number. So, what we're going to do first is we're going to take this 1 1/3 and convert that to an improper fraction. Because we know that we're going to have to be dividing at some point. We can't divide with mixed numbers. So, off to the side, we know that 3 times 1 is 3 plus 1 is 4, so that's going to be 4/3 miles over 1/4 hour equaling x over 1 hour. Now we're going to find our unit rate. And to do that, we're going to solve the proportion by drawing in our band-aids, because right now my proportion is broken. There's a missing part. Band-aids make everything better, so we're going to multiply what's in our band-aids. Okay? That gives us 4/3 times 1 equaling 1/4 times x. 4/3 times 1 is 4/3. That equals 1/4 x. Don't rock. If you need to stand, stand, but don't rock. That equals 1/4 x. Then what we're going to do, we need to get our variable x by itself. So we're going to divide both sides by 1/4. And here we have a complex fraction that we need to simplify. For the sake of space, I'm going to move it over here. 4/3 divided by 1/4 is equal to 4/3 times 4 over 1, because I KCM'd it. What does my K stand for?
Keep.
What does the C stand for? To what operation?
Multiplication.
And what does M stand for?
Multiplicative inverse.
The multiplicative inverse. Our favorite thing to say. Yes, ma'am. The 4/3 here? Because that's what we keep. Oh, in the band-aid? Because 1 1/3 written as an improper fraction is 4/3. Because 3 times 1 is 3 plus 1 is 4.
Oh, that's a 3. I thought it was 5.
Oh, I'm sorry. Nope, it's a 3. Okay. 4 times 4 is 16. That means that 16/3 is our answer. Do I like 16/3 as an answer?
No.
You don't.
Yeah,
We need to
simplify it.
We need to simplify by turning it into a mixed number. 16 goes inside my house as my numerator. 3 goes outside. 3 goes into 16 5 times. 5 times 3 is 15. Subtracting it 1. So that means that we have 5 and 1/3. We're going to put this back into the context of our problem. So that's 5 and 1/3 mph, or miles per hour. What questions do we have? Yes, ma'am.
Oh.
Mm-hmm. Okay. Do we have questions? No? this is what we're doing today. We'll be solving problems that ask for the unit rate that require us to use complex fractions. Okay?